First thing I would do when I'm trying to rewrite this function as a piecewise function is just graph it and let's see what we're looking at. So I'm going to graph y equals absolute value of 6x plus 18. And there we can look at it. So if we're looking at this in terms of a piecewise function, it's got two parts, right? It's got the left side and the right side. Each one is going to have a distinct equation, and it's going to be split up by a specific domain. What I can see is that from negative infinity to negative 3 is going to be one equation, and then the second piece is going to be from negative 3 to positive infinity. So the way you could get that algebraically without even graphing it is to figure out what's the translation. The horizontal translation is based on what you're adding inside, but that number you're going to have to divide by a coefficient on the inside. So if there is a coefficient inside like this one, you have to divide it. So 18 divided by 6 is 3. It's plus 3. So that's why it's moving left. All right. So that's why on the graph, negative 3, the vertex moved left 3, which is what we just found algebraically. But that's why that's the part where the two pieces of the function are going to be split up. So for the domain, we're going to write the domain as an inequality instead of interval notation. So we first have all the x values that are less than negative 3, and we have all the x values that are greater than negative 3. Okay. I guess you could pick one to have the negative 3 be part of it. It doesn't really matter. It's one or the other. It technically can't be both. But it doesn't make much difference which one it is, honestly. Now you have to figure out what are the equations for both parts. Well, the way it's going to end up is, well, if you look at the right side, for instance, that is exactly 6x plus 18. So it's just whatever the absolute value, whatever's on the inside, the absolute value. So 6x plus 18. The other one is the exact opposite of what's inside. So on the negative side, it's the exact opposite of what the equation is on the inside of the absolute value bars. So that's going to be negative 6x minus 18. And if I'm just writing a function notation, it's going to look like that. Okay. Again, you can go through the whole solution written out in the book, but I think that's it. They're going to suggest graphing it at the end. I would suggest graphing it at the beginning, and that way you get a sense of what it looks like before you start working with it. Okay, let's take a look at the next one. Well, the you try questions. So at this point, I would try both of these on your own and see how you do, and then I'll come back and explain for you. The first thing that jumps out to me is the fact that you've got the negative inside there. Don't let that confuse you. That when you see a negative in an equation, sometimes you automatically think, well, that's what's going to flip it. That's what's going to make it reflect over the x-axis. But when it's inside absolute value bars, it's not. A negative on the outside of the absolute value bars is what would make it reflect over the x-axis. So that's not happening here. It is going to have a slope of 5, but it's still going to open up. Again, because it didn't get reflected because the negative's on the inside. What that negative is going to play a role in is the horizontal translation, because it is based on the minus 10, but you have to divide the minus 10, the negative 10, by the negative 5. Negative 10 divided by negative 5 is positive 2. So it's going to go left 2. Okay, so then negative 2, again, since it went left 2, is going to be that vertex of the absolute value function, which is going to be the part of the piecewise function where it splits. Let's go ahead and graph. So I'm going to graph absolute value of negative 5x minus 10, so that way we can see what we're looking at before we do it. So again, it does move 2 to the left, and it's opening up. It's got a slope of 5 on the right side, a slope of negative 5 on the left side. So again, negative 2 is going to be the spot where the domain splits. So we're going to have all the x values less than negative 2 and all the x values greater than or equal to negative 2. So I'm first going to list out the domain. So you have all the x's that are less than negative 2 and all the x values that are greater than or equal to negative 2. When I go and look at the equation, what would the equations be for each part? The right side is going to be it's actually going to be 5x plus 10. So since that's negative, then the right side is going to be what's the opposite part. So what's on the right side is going to be the 5x plus 10. And what's going to be on the left side is going to be the negative 5x minus 10. All right. And then it's in function notation, the f of x equals. Okay. Let's take a look at part B. So in this case, the negative's on the outside. So this one's going to flip upside down, and the plus 3 is going to move it up 3. So let's graph that to get a sense of what it looks like before we do anything else. So we're going to type it in, negative absolute value of x plus 3. When we graph it, looks like that. So the inflection point, the vertex point, but where the piecewise function breaks is at 0. So I can at least list out the domain first, where we've got x is less than 0 and x is greater than or equal to 0. Now for the equations of each of the parts, on the right side, we've got, it's a slope of 1 because it's just the x, and then the y-intercept is 3, so it's x plus 3. Again, that's on the left side. On the left side, that's where it's going up. And then on the right side, it's going down. So it's going to be x minus 3, and negative x. Again, it's going to be negative x minus 3. When you go ahead and you check your answer on that, that's what it should be. Let me know. Well, let's go through example 5, and then you guys can start the practice. I may have misspoke. It's negative x plus 3, right? I think I might have said negative x minus 3. The y-intercept is positive 3. All right, sorry about that. Okay, so let's try example 5. So load up that video next.